Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, Arithmetic Slices to Subsequence. So basically here we have an array of numbers like this, and we want to return the number of all the arithmetic subsequences. Now what do they mean by arithmetic subsequence here? Is basically if it has at least three elements, three numbers, and the difference between any two consecutive element is the same. Okay, so for example, if we take a look here at this first one, the difference between 3 and 1 or 1 and 3 is minus 2, between 3 and 5 is minus 2, between 5 and 7 minus 2, between 7 and 9 minus 2. So it's the same difference between each consecutive two elements. And the length is more than 3, right? It's 5. And so this one is a valid arithmetic subsequence. Here as well, the entire thing is a valid subsequence, is a valid arithmetic sequence, and then here the difference is 0, 0, 0, so valid as well. Here the difference is minus 4, so 3 minus 4, that's minus 1, minus 4 gives you minus 5, minus 4 gives you minus 9. So this one also is a valid arithmetic sequence. So that's the idea. This one, however, is not, because you have the difference here 0, but the difference here becomes minus 1, and then here becomes minus 3. So you can see it's not the same difference. So that's the idea. Now, the key here is a couple of things. The first one is that we are looking for a subsequence, which basically means it's fine to have, like, let's say, for example, in this case, 2, 4, and then maybe, is there another valid one? No. But if you had, let's say, 6 here, then 2, 4, 6 would be a valid subsequence. So basically, subsequence means you can skip some elements, like here we can skip 1. Okay, so that's the idea. Now, the constraints are not too big, it's up to 1000, so this tells you that you can do some sort of n-squared solution. And the other thing to pay attention to is, if we look here at the first example, is so 2, 4, 6, 8, 10, the entire thing is a valid subsequence, is a valid arithmetic subsequence, the entire array. But also 2, 4, 6 is valid, 4, 6, 8 is valid, right? 4, 6, 8 is valid, 6, 8, 10 is a valid subsequence, as long as the length is bigger or equal to 3. 2, 4, 6 up to 8 is valid. 4, 6, 8 up to 10 is valid subsequence. So we need to count all of these, that's what you see here. Okay, but also another one that has a different value difference, which basically means, so the other ones all have a difference of minus 2. But if we take 2, 6, and 10, the difference is minus 4, right? It is a plus, 6 minus 2 is 4, right? So the difference is 4 if you do it on the other side. So, and then between 6 and 10, the difference is 4 as well. Okay, and so this is a valid subsequence, because if the difference is the same between 2 and 6 and between 6 and 10. Each of them is minus 4. And so this one is a valid subsequence as well. Okay, so these are the couple of things that you need to pay attention to. Okay, so how do we tackle this this problem here? Well, a couple of things I wanna. The first thing to start with is, it's really hard to come up with like any greedy or whatever, greedy or some sort of heuristics to solve this with. And so in that case, let's think about, it's also just like a subsequence. It's the number of subsequence. It's counting a number of subsequence, and in most cases, counting the number of subsequence, like we have LCS, we have a lot of dynamic programming problems that deal with counting subsequences for an array with some criteria, right? And so immediately when you have a problem like this, dynamic programming should be one of the solutions you think about. And so that's what we will think about here, is dynamic programming. But again, since dynamic programming is usually harder, at least for me and for a lot of new people, for a lot of beginners, it's hard to do the tabulation technique. Think about the recursive version, and that's usually a lot simpler. Now, for the recursive solution, we need to think about what's the state we need to come up with to solve the problem. And so let's just take an example here and think about it for a second. So let's say we have 0, we have 2, we have 1, we have 4, maybe 5, 6, maybe 9, and then maybe 8. Yeah, maybe let's keep it sorted just for the sake of easy processing. Okay, so if we think about it this way, then what's what's sort of the condition here for an arithmetic subsequence? Is basically the difference needs to be the same between two adjacent elements, right? So for example, here the difference between the two is -2, 0 minus 2. That's 2. Let's do it by basically difference between g and I. And so if we do that, then that would be 2 in this case, right? So that would be 2 here between this one. If we take this as the next subsequence, the difference is 2. If we take this as the next one, difference is 2. So our valid subsequence contains these. And of course, like just 0 to 4 is valid, right? And just 2, 4, 6 is valid, as long as the length is at least 3. And so one state we can think about is, what do you need to determine the difference? Because that's the key point here, is the difference that we need for the next element. Okay, what's the two values that you need? You just need the two first elements. You only need the two first element to determine what's the difference. And so let's do exactly that. Let's have as our state I and j, and these basically, let's call it dp of I and j, and this is basically going to be the number of subsequence, okay, that start at I, j pair, okay, which means basically it's the subsequences that have the arithmetic subsequence, of course, that have the difference equal to basically a of j minus a of I, right? So this is what we want to count here. And so now the question becomes, each time, right, how do we find once we have two elements, how do we find the number of all the other ones, right? And that's the key point here. So how do we do that? What we can do is, when we have, if we know the difference, then what's the next element? Well, the value of the next element is going to be just the value. So you have I and then j, this is the order of the indices, and then you have some other index here, let's call it index. Okay, now this index is where we have the next value. Well, we know for this to be part of the arithmetic subsequence, it needs to be a of j plus the same difference between ai and aj. So this is the difference between ij minus ai. So it needs to be plus the difference. So all we need to do to find if we have another index that we can add to our subsequence is to find a next value that is equal to this, right? Because the only way for it to be part of the subsequence that starts at I and j is for it to be equal to the previous element in the subsequence plus the difference. Like for example, 4 here, the only way for it to be part of the subsequence is for it to be equal to 2 plus the difference, which is equal to 2, right? And so we just, in this case, once we are at this point, we need to find 2 plus 2, right? We need to find 2 plus 2, 4. And so how do we find, now the question becomes, how do we find if 4 exists? Well, that's easy. We need to just do some pre-processing at the beginning where, let's call it index to value, where we put, for each value, we put its index, all of its indices. So maybe let's say, for example, in this case, if we had another 4 here, we need to count both 4s. And so we need to keep track of the indices of both. And so let's actually do that with 4, and let's take this array and write our index to val here. So in this case, let me just put this here so we can see it. And then in this case, we would have 0, 1, 2, 3, 4, 5, 6, 7. So we would have 0, we have just one index, 1, we have just one index, for 2, sorry, and then for, let's put this down a little bit more. For 4, for 1, we have index 2, for 4, we have two indices, 3 and 4, and then for 6, we have index 5. For 7, we have index 6, and then for 8, we have index 7. Okay, so how does this help? So let's say we start maybe, how do we go through all the starting two values? So to do that, we can just, since the number of elements can be at most 1000, we can just try all two values as the starting of our arithmetic subsequence. Okay, that way also that will take care of the fact that starting at 2, we have 2, 4, 6 as a valid subsequence, right? 2, 4, 6. If we, that will take care of it because we also have an instance where we start at 2. And so to do that, we can just go through all in the range of the indices, the length of the array, okay? And then same way for j, we go through in the range of n, okay? And then we just, our overall count of the arithmetic subsequence, we can just add up the number of subsequences that start at I and j, right? Those are unique, right? Because we only take I and j once. J needs to be after I, so this needs to be I plus 1 to n. Okay, and then this is what we return. Okay, so which means basically first we'll try 0 and 1. After that we'll try 0 and 1 indices, so 0 and 2. Okay, so we try to find all the arithmetic sequences that start with 0 and 2. In that case, that would be 0, 2, 4. Okay, 0, 2, 4, 6. 0, 2, 4, the other 4. Okay, and then 0, 2, 4, 6 for the other 4 as well. And then 0, 2, 4, 6, 8. And then the same one, 0, 2 with the other 4, 6, 8. I think that would be it. And okay, so that's for starting with 0, 2. And then we will try to start with 0, 1, okay? And now the difference would be between the two is 1. And so we'll look for another element that is equal to 1 plus 1, which is 2, right? And so in this case, but we need to look for an element after this index. So we won't find it. And so we stop here. We don't count it because it's just 2 elements. Okay, and then we start with another 2 sets of elements. So we start with 0, and remember we start with I equal to 0, and then we go through all the j's. So we start with I equal to 0, and then we go to 4. And so now we are looking, the difference is 4, so we are looking to 4 plus 4, which is 8. And so we find 8. So we have our subsequence here. And same thing with, we find the first 4, and then after that we find the second 4. So the second 4 as well. Okay, so we have 2. So we keep going like this until we reach the last I and then the last j. Okay, so I hope that makes sense, but that's the core idea here. And so you can see a couple of things we did here in this DP of I and j. So one thing we did is that we take the 2, we know the difference is going to be between the same, needs to be the same between these two, so ij minus ai. And then we look for the next element, which is going to be, since the last index is j, we are looking for aj plus the difference. Okay? But we want this element, these indices to be in order, so we are looking for the next index after j. And so since we have, that's why this map comes in handy. For example, in the case of 4, we want to look for the first index after j. Now remember our j, for example, in this case, let's say for 2, our j is 1. We are looking for the first index after 1. And so we can just, maybe this was bigger. Let's say maybe we had a 4 here before this 2. Then in that case, we don't want to find, let's say 4 was at index 1 and maybe 4 at index 4 and then at index 5. And j is equal at index 2. We want to find the first index after 2, so we want to find this one. And so how do we do that? well, we can use binary search because we know this list can be sorted because we go through the indices in the order of the indices of the array. And so we can just binary search for the first index after j that has the value of next. Okay, so let's call that index. And so we can just use binary search. In this case, Python, you could just use bisect. Bisect. I will explain why bisect left, but instead of bisect right, but just bisect left gives you the first one, the index, the insertion point before the first one. So basically it will give us 4 in this case. And so what do we search for? Well, we want to search for the indexes of the value of next. And so that's what we use here in our map that we call index to val. And so we'll look for index to val for the number next, right? So that's what we will be looking for. But we want to look for the index after j plus 1. We don't want j itself, we want the index after it, so we will look for j plus 1. Anything, the first element after j plus 1. Okay? So that, and we are using bisect left so that if it's exactly j plus 1, we get j plus 1, not the element after that. Okay? And now once we have the index, we can just remember, for example, when let's say for the case of 4, we want to consider all of them, 3 and 4. And in this case, we want to consider all of the valid ones, 4 and 5. So what this means basically is that we want to, for the result, what we want to return, we of course want to recurse on starting from the two next elements, which is j and this element at k, let's call it k, j and k. What is k? K needs to be anything from index forward, right? Because we want to try 4 to 5, and here we want to try, in this case, 3 and 4. So all of them, starting from anything bigger than j going forward. And so for k in the index to val of next, starting from this index, right? Which basically guarantees that it's going to be bigger than j going forward. Okay, and we add 1 because we just found, because we are considering I and j as part of the sequence. So this one here for the length is part of the sequence. And we take the sum of all of these, right? Because we want to consider, for example, in the case of 4, we want to consider 0 to 4 for the first 4, and then 0 to 4 for the second 4. Okay, and that's roughly the idea here, and then we return this. Okay, so again, to reiterate, we'll try every 2 elements as the starting point of our arithmetic subsequence, and then we will look for any element after the index of the second element of our pair that gives us an arithmetic subsequence with the same difference, right? And we will count all of them like we did here. Okay, I hope this makes sense. If it didn't, just rewind and think about it more. But I think this is a lot easier to understand than the tabulation technique. So let's write the code and make sure it passes. Okay, so now we need to write the code in this case. So what do we need? We said we will start. Of course, let's just make this a. That would be easier. And n is equal to the length of a. And so j is going to be anything after I, okay? So we'll try every pair basically in this case. And so we'll try I and j. So we'll start our state here, but we also need the overall count of arithmetic subsequences. And so this is what we need to return at the end. And now we'll start our dynamic programming recursive function here. So what is this? So basically this is the number of arithmetic subsequence starting with pair at indices I and j. Okay, and now in this case, for this, we know that the difference for our arithmetic subsequence needs to be aj minus I, as we said in the overview, and we know the next element needs, since its index needs to be after j, it needs to be aj plus the difference for it to be an arithmetic subsequence. But we also need the index to val map that we we said we will look for, so we only just need to do enumeration here for all the elements of A. Enumerate of A, and let's have our index to val map. And then we will, now in this case here, I will make it by default a list because that's what we need in case there are duplicate values. So index to val for A, we'll just add the index I here. Now the elements here will be in order because this I goes in order, right? The indices order for the array. Right? Maybe it's more clear if we do range of n here. Now then in that case, this is going to, you can see that it's in order, and then we have A of A. Okay, and now we want to find the next index that has this value, the closest index to J that has this value. So we use bisect. We know the list is sorted, so we use bisect left. Now we are searching in this for the value next. And we are searching for an element that is bigger or equal to J plus 1, okay? Because we need the index after J. So let's call that index. And now we need to return, we need to recurse. We have the length of 1 because of these two pair, plus dp of, now the new pair we want to start from is J to this index, starting from this index. Now we can do index like this, but remember, if we have 2, 4, 4, 6, 8, 10, we want to try 2, 4, but we also want to try 2, 6. Because it happens that 2, 6, 10 here is a valid arithmetic subsequence. So that's why index alone is not enough. We need to try the one after that index, but anything after it that has the same value, because we also want to do 2, 4 here in this case. The first 4 and the second 4, even if you have, let's say, for example, 4 4s, you want to take this one, and this 6, and then you want to take this one, and this 6, and then you want to take this one, and this 6. So you want to go through all of them. And so you want to do, in this case, you want to do k then for all the k's that have the same value next, because they have the same diff, right? Because of this, okay? And so, but we want to start only from index, because let's say if we had maybe 0 like this, but we had a 4 here. This, we don't want to take this 4. We want to take 0, 2, and then these 4s. Because the indices has to be, because we are already starting from the premise that the starting point of the subsequence is I and J. Okay, so this needs to be index going forward. Okay, and that's pretty much it. Now this needs to be the sum. We want to take the sum of all of these subsequences. Okay, so we need to also catch this solution because there would be repetitive states from this recursive call. You could use a hash map, but I'll just use a normal, like a simple annotation. So if we run this, looks like it passed. If submit, it goes through as well. Okay, so yeah, so I think the solution is a lot simpler with the recursion. I hope this was easy to understand. If you need help, reach out to me in the super peer link in the description below. Yeah, so that's pretty much it for now. Thanks for watching, and see you on the next one. Bye.